it's the theory under differentiation. So I'm only going to focus on the differentiation rules. So you're more than welcome to go through the theory. Differentiation in mathematical economics is used to analyze how one variable changes in response to another. It is a key tool for studying things like optimization, in bracket maximizing profit and minimizing the cost, and marginal analysis. You'll realize that every time here we talk about maximizing profit and minimizing the cost. So that's what we're going to do also here using differentiation. Differentiation measures the rate of change of a function. So in differentiation, we have the rules. So we are going to focus on differentiation rules. You're more than welcome to go through the theory of the first part. And then those who went through the theory of differentiation, you'll realize that they're talking about finding the slope at one point. Reason being is that our graph here is a curvy, it's a graph that has a curve. It's a quadratic graph. It can also be the cubic graph. So to find the the slope, not the gradient. So your graph looks something like this. And then to find the slope at one point, we draw a line that is tangent. Tangent meaning that it touches your quadratic graph at one point. So to find the slope at this point, you need to differentiate. So that's why we're gonna do we're gonna go through the differentiation rules. So because we said that in this module, we're not gonna focus on the graphs, we're going to focus on the calculations. So I'm gonna start with differentiation rules. The first rule is called the power rule. So the power rule, they're saying that if you are given the f of x, this is the function, is equals to x to the power of n. So if you are given this, then when you differentiate, this is the differentiation rule for the power rule. If you differentiate, you can only differentiate if your function is a x to the power of something, or maybe p to the power of something. It must have an exponent. So you are going to say, you're going to take this exponent and put it here, and then say x to the power of -1. So we always -1. So these two things are the same. These two are the same. I said, or if your function is given as y is equals to, then you can do it this way. But because our module, when we get assessed, it's a multiple choice. So whether you do it, you say dy over dx, or you say f prime. So when we put a comma here, we call it a prime. So this is f prime x. This shows that you are differentiating for the first time. And then you'll notice that as we move on, we do what we call a second derivative or first, third, or yes. So this is the first derivative we're deriving for the first time. So it has it's a f prime. But if you're given y is equals to, you're going to say dy over dx. So we are differentiating the function of y with respect to x. Again, you're going to understand what I'm talking about as we do the examples. The second one, okay. So the second one is this one. Okay. 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 All right, my pen is not working. Gosh. Okay, give me a second. My pen is not working.
Excuse me, teacher. Are you here? Excuse me. Mm. 为什么没有网啊？
没网了吧？
Okay, I'll try to see. Okay, all right. And then the second one is this one. Okay, can someone please assist here? My pen is not writing. I think it's okay. Let me try to switch it on. Anyone who has an idea on how to switch this one on? This pen on. Gosh. Anyone who can assist? I disabled something here. Anyone?
Maybe you can stop sharing and share and just try to share again. It'll probably
Okay.
work.
Nope, that's not helping.
Have you tried the undo button?
Masero, hi,
Yes.
sorry. Try to close the document and open it again.
And open again. Okay, thank you.
Yes.
Thank you.
Also, you can try to press the escape button, the small button, the escape button.
Oh, there's escape. Okay, wait, let me try to open it again. Hmm. Oh, okay, it's back. Oh, I thought it was my battery. Thank you very much. Yeah, that works. Thank you very much. Okay. Then as I was saying, and then here we are saying that if you are given this function, f of x, so if you are given this function, this one, if it's given as f of x is equals to k, then x to the power of n. So k here is your constant. So this is a constant. Constant meaning that it can be any number. So if your function looks like this, k then times x to the power of n, when you differentiate, it's going to be f prime x is equals to this k times. And then now you continue with what we've been doing here. So you're going to continue and say you take the n, you put it here, and then it's going to be x to the power of n minus 1. N is an integer. It can be any number. N is a number, actually. Can be any number. It can also be a fraction. And then also, if you are given as y is equals to, then you're going to say derivative of y with respect to x. So it's just going to be the same thing again. Again, it doesn't really matter whether you say dy over dx or you say f prime x, because your questions are multiple choice. So this is another one. And then we are saying that now, if you are deriving a constant, remember I said that k is a constant, meaning that it can be any number. So if k is a constant, the derivative of a constant is 0. If I say derivative of 1 is 0, any number is a 0. So these rules are very important before we can start the example. So I'm going to apply this on the example so that it can make sense. I understand that some of you, this is new to you. So I'm going to try and help you understand. And then now let's go to the example. The example says that differentiate each of the following functions by using the power rule. So we're going to use the power rule. So my function is f of x is equals to x to the power of 5. So when I differentiate, I'm going to say f prime x. So this is just going to be f prime x, and then this is equals to, sorry, this is equals to, then I'm going to take the 5 and put it here. If you can remember, that's what I said. So I'm going to take this 5 and say 5. And then this will be x. And then this is 5, then minus 1. So it's 5, then 5 minus 1. So this is the rule. That's how you differentiate using a power rule. So this will be 5 minus 1. And then now it means that now my answer is going to be 5x. Then 5 minus 1, it's 4. So this is how we differentiate. This is how we differentiate. And then now let's look at this one. I'm going to do this one and show you again. So we are going to differentiate. So when you differentiate, please, you have to make sure that you have a variable and the exponent. There must be two things. It must be like this when you differentiate. But when you look at this one, it's 1 over x to the power of 3. So it means that I cannot differentiate until I put it in this form. So that's what I'm going to do. So before I can differentiate, I cannot write the prime if I'm not differentiating. So I'm going to say this is going to be equals to, before I start differentiating, I'm going to say this is equals to. And then I'm going to take this x to the power of 3 to the top. When you take it to the top, you are going to have x to the power of -3. So when you take this x to the power of 3 to the numerator, it becomes a -3. There's a rule that says that when you have a fraction, if you have 1 over x to the power of n, this can also be written as x to the power of minus n. There's a rule, exponential rule. That's what we're going to be using for the power rule. So if it's to the power of n, when I change it, it's going to be a -n. So x to the power of n can be written as x to the power of minus n. The sign changes when you take the number to the top. So this will be a -n. That's a rule. So now
Sorry,
I
ma'am.
have, yes.
I didn't understand your first example.
Yes, please listen on this one. You'll understand. I'm doing it again. Eh? So
Okay,
we
no.
have, yes. So our function, we have x to the power of -3 because I moved this x to the power of 3 to the top. So it becomes x to the power of -3. So now I have my function as x to the power of -3. So when you are differentiating, the rule says that, let me rewrite it here. So now I have f of x is equals to x to the power of -3. The rule says that when you have something like this and then you have to differentiate, remember the question says differentiate each of the following functions. These are your functions. We are differentiating. So when you differentiate this, firstly, you need to say this is going to be f prime. This comma here at the top, we call it a prime. So it's f prime x is equals to, when you differentiate, you're going to take this 3, the -3, you put it here. That's the rule. So you're going to say -3, and then you write x, and then to the power of this -3 minus 1. That's the rule. -3 minus 1. And then now you solve. So this is just going to be equals to -3, and then x, and then -3, -1. What do you get? Someone help.
-4.
Thank you. -4. This is how you do it. So when you differentiate, the rule says, here's the rule. Please look at the rule. The rule says that when you differentiate using the power rule, your function must be x to the power of n. When you differentiate, you're going to take this n, you put it here, and then you say n minus 1. N being any number. N is an any number. That's how you differentiate. And then we are saying that now if your function is given as k and then x to the power of n, k being a constant, you are going to say k times the same thing that you're doing here, you do it again, n, then x to the power of n minus 1. I saw a hand up. Please ask your question.
Can you hear me, Miss Masero?
Yes, I can hear you.
Okay, I just want to know, so in every function that we get, we always say -1 every time. It
Yes,
doesn't change.
exponent every time.
Okay.
Yes.
Okay, thank you.
Thank you. We always -1, yes. I saw another hand. Okay. All right. And then now let's go to B. So that's how we differentiate in Mhlengi. Yes, you can ask your question.
Hi, Masego.
Hello.
Sorry, man, I'm a bit lost here. So I'm still stuck at A, where you say F into X equals X to the power 5. I get that part.
That's
The
the
second part is
question.
where I'm a bit lost. Yeah, I'm a bit lost in the second part as to the 5 that's a whole number to an X. Where did you get that from?
The rule says that if, for an example, you are
Sorry, can you
given.
hear me?
Yes, I can hear you. Can you hear me?
Hello?
I can hear you. Can you hear
Hello?
me? Can you hear me? Sengi, can you hear
Oh
me?
my gosh. I can hear you now.
All right. So the rule says that's a rule, ne? The rule says that if you are given y is equals to, or f of x, it doesn't matter. F of x
Okay.
and y is the same thing. Y is equals to x to the power of n. The rule says that. Can you hear me?
Yes, I can hear you.
All right. So the rule. So this is the question. If I say to you differentiate, ne? This is the question. The rule says that you are going to say. Okay, let me just do this. It's going to be, you take this n, you put it here, and then x. And then this n, you must always -1. So if you have x to the power of 5, when you differentiate, if I say my question is this, when you differentiate, you're going to have, take this 5, you write it here, x, then 5 minus 1. Do you understand, Mhlengi? Okay. Seems like I lost Mhlengi. All right. Let's go to B. Can we go to B? Then I'll take questions. Ne? Noted Stembile, can I go to B? And then you can ask questions. Whether you say it's f of x or you say y, it's the same thing. Please. Y and f of x is the same thing. Please. Number B says f of q is equals to, so this is the function. This is what we call a function. This is a function. And then when you differentiate the function, this is going to be f prime. You put the prime, which is a comma on top, then is equals to, then the rule says that if now you have this 10, remember the rule said, if you are given f of x is equals to, why am I putting x here? It's q, ne? Sorry. The rule says that if you are given, then I said k is a number, then x to the power of n. The rule says that this is the rule. The rule says that when you differentiate, you are going to say f prime x. Then you take this k, and then you say times. You take the n, we repeat the same thing. Take the n, write it on the side. So it's going to be n, and then this will be x, and then this will be n minus 1 every time. Then it's going to be n minus 1. This is the rule. The rule says that if now you have a k, let me write k with another color. K, I'm going to use green. K, I'm going to write k with green so that you understand. This is k. This is k. That's the rule. You are given this. You are differentiating. Now I'm going to do it here with this one now. I am going to do it with this function here. I am given f of q is equals to 10q. So 10q to the power of 8. What is my 10? My 10 is k in this case. This is k. I'm going to, I can't write it with enough. This is k. This is n. Now let's differentiate. This is going to be f prime q, because now it's q. The variable is q, it's not x anymore. We do the same thing. Is equals to 10 times x. Oh, q. Oh, sorry. Yeah, sorry. It's q. Sorry, q. Okay, sorry. Okay, why can't I erase this one now? Q. Okay, it doesn't want to erase now. Okay. It's q. Okay, sorry. Thank you. So it's going to be q.
Sorry, ma'am.
All right. No, why are you saying it's q? It's 8.
It's
Yes.
8.
Hey, guys. Yeah. It's 8. This is 10. This is 8.
ma'am.
Yes, thank you. It's 8. And then q. Thank you. Q to the power of 8 minus 1. Every time. 8 minus 1. Please, this is the rule. Please follow the rule. Just follow the rule. And then the more you practice, the more it's going to make sense. This is equals to, then now it's, what is 10 times 8? It's 80. It's 80. 80. And then q. And then 8 minus 1. It's 7. Thank
7.
you. Yes. Someone's hand was up. Please ask. And if you feel like you are still lost, you can still go back to the video because I think I am recording. And then again, you are going to catch, as we move on, I'm going to keep on using the same thing over and over again. Then it's going to make sense. I'm going
Okay,
to keep
thanks.
using, yes, I'm going to keep using the same thing over and over again. And the more I do it, the more it's going to make sense. First time, you might not get it because I understand it's new. Not all of us did maths. I understand that. So I'm saying to you, be patient. As I do it, you're going to see we're repeating the same thing over and over again. Is that fine? There was someone who wanted to ask the question. You can ask. You're more than welcome to ask. You can ask before I move. This is what we call the power rule. I think it's called the power rule because of it as an exponent. You can ask the question.
Hi, ma'am. It's
Hello.
Timbile. I
Yes,
raised my
Tembile.
hand, but then my question was actually answered. But just
Okay.
to ask the question, so the eight, you see where you have 10 times 8q, and then 8 minus 1. So that 8 down there will be the same as the 8. Like those numbers will be the same. Like we won't find.
Yes.
Okay.
That's why
So
I'm
it will
saying
never be like
that's why I
different
wrote it here.
numbers.
No, that's why I wrote it here. It's a rule. The rule says that if you have k, then x to the power of n. When you differentiate, it's going to be this k, you write it here, then times this n, then x to the power of n, then you minus 1. You always minus 1.
Okay, so it's always the ends will always be the same number.
It's, yes.
Okay,
You
ma'am.
minus 1 from that n. So it's going to be n, then n minus 1. Yes.
Okay, ma'am.
Yes.
Noted.
All right. So let's do it. You'll see as I do examples, it's going to make sense. I'm going to use the same thing. So now here I said, this is the hint. Ne? As I said, I know that most of us didn't do maths, so I'm going to do, yes, so that you get it. So the hint says that if you are given B is any number, A is any number, you write it as x to the power of A over B. Remember the rule. The rule said that you differentiate when we have x to the power of something. There must be something here. Or it can be a k, then x to the power of something. It must look like this for me to differentiate the function. It must have an exponent because we are doing the power rule. This is what we call the power. It's x to the power of n. So I cannot differentiate if I don't have the power here. I don't have the power. So let's change this so that we can be able to differentiate. So the hint says that if you are given a root and there's a smaller number there and then the 2 there. So this will be, let me also write it here so that you can understand. So sometimes it can be like this. If it's the square root of x, this is going to be, there's always a 2 here, but we don't write it. So this is just 1, it's x to the power of 1 over 2. Please, the square root is a half. This is a 1 over 2. So now let's do the example. I'm just writing this here so that it can make sense. It will make sense, don't worry. So now let's come here. This is the function. I cannot differentiate until my function is fine. It has an exponent or a power. So this will be, I'm going to rewrite it now. So it's going to be f of x is equals to, whether you say y or f, it doesn't really matter. I'm interested on the right side. So this will be x to the power of. I said if it's b outside, then a here is going to be a over b. So a in this case, it's 2. B in this case is 3. So I'm going to do that. My a, I'm just going to use these colors. This one, okay. Okay, let me try again. Jesus. Okay. This testing the patience. Okay. All right. Thank you. So this will be A. I'm gonna use blue one. So this is gonna be, my A is 2. So this will be 2 over, and then my B is 3. I'm going to do it like this so that you can see it, you can compare it. I'm gonna use colors. Be patient with me. So this will be x to the power of 2 over 3. Every time. This will be on top, this will be at the bottom every time. So now my function, it has an exponent. It looks like x to the power of n. My function now has an exponent. Now I can start differentiating. The rule says that if you have x to the power of n, if you have f of x is equals to x to the power of n, the rule says that the prime will be n, then x, then n minus 1. Let's do that. This will be f prime x is going to be, okay, let me write the rule here again. Makes sense. I want it to make sense. F prime, okay, no, f prime x, sorry, is equals to, you take your power is 2 over 3. You are going to take this 2 over 3 and write it here. This will be 2 over 3. And then when you are done, you minus 1 from that 2 over 3. 2 over 3 x, and this will be 2 over 3 minus 1. That's what we mean. 2 over 3 minus 1. That's what you're doing. And then now you get your answer. Now you're done. This is the prime. This will be 2 over 3. What is 2 over 3 minus 1?
Negative
Someone
0,
has
1,33.
Negative 1 over 3.
negative?
1 over
1
3.
over 3.
1 over
Negative 1
3.
over 3. Are we together?
Yes.
So sometimes you will notice that on your, oh, but let me leave it here for now. To make this positive, or I cannot, yeah. So you can either write it this way. So it's going to be 2 over 3. As I said before, when you move the exponent, you can write this. If you want to make this positive, you can say this will be 1 over. What is my b? My b is 3. It's up to you, honestly. So this is going to be the root. So this will be a cube root. My b is 3. So you can write it this way if you want. That's if you want. And then my A is 1. It's up to you, honestly.
Ma'am,
Again, yes, there's a 1
there
there. You
be
don't need to write it.
will there be
Sorry?
need, will there be a
No,
need to like write it in that form?
no. It depends
Oh,
on the multiple choice. So if
oh,
it's
okay.
like this, probably they're just gonna write it like this on your when you're doing your assessment. Honestly, they're just gonna say if you want to make this positive, so this will be now x, then to the power of a positive, not a
Well,
negative.
yes, it's gonna be 1/3.
Yes, thank you. 1/3. Yes, that's it. We have a rule of exponents. We are saying that if you want to make an exponent positive, it's either you move it down or up. You'll see when I do this one now. Let's do it again. I'm going to do the example again so that if you didn't get it when I was doing this one,
Yes, miss,
you
please.
can get it. Yes, I'm going to do this one so that it makes sense again. I am saying the rules are you cannot differentiate if your function is not in this form as x to the power of something or q to the power of something. You can't differentiate. So our function here, we are differentiating with respect to q. Here I was differentiating with respect to x. So I'm going to do it again so that it makes sense. It must be in this form of x to the power of something because it's a power rule. So I'm going to do it again. We are saying that we cannot differentiate when it looks like this. It looks funny. And I said here, I said that if you are given, this is a hint. Let me just write it as a hint. A hint, we are saying that if you are given the square root of x being a variable, please mute your mic, x being a variable, you must change it, please mute your mic, you must change it to be x to the power of 1/3. We call this a square root. So when you change this to have a power, it's going to be x to the power of 1/3. What is my 1/3? Is this square root? There's always a 2 here, but we don't write it. So we call this a square root. And there's always a 1 here, but we don't write it. So every time you have a square root, this will be x to the power of 1/2. If we have what you call a cube root is going to look like this. When you change this to have a power, it's going to be x to the power of 1/3. That's how we do it. These are the hints so that everything that I'm going to do makes sense. So now we want to differentiate. You cannot differentiate if you don't have x to the power of something. We need powers because it's a power rule. So this is going to be f of q. I'm changing. This is just 4. I'm not going to touch this 4. I want to change this root. This root is going to be a q to the power of 1/3. How did I get this q to the power of 1/3? It's this cube root of q. It's a square root of q, not a cube root, sorry. It's this hint that I showed you. I showed you the hint. Here's the hint. So it means that when I change this, I am going to have q to the power of 1/2. And then over q. I changed the q root. Let me write it here so that it doesn't waste my time, our time. So the square root of q will be q to the power of 1/2. So it means that here I am going to have q to the power of 1/2. And then now we have this q at the bottom. If you want to take the q at the bottom and take it to the top, because we need to differentiate. So if I have something over q and I want to take the q to the top, this will be q to the power of -1. But let me not overwhelm you. Let me do it so that it makes sense. So I changed this one first. Let me do that. So this will be over q so that I don't overwhelm you. So this will be over q. And then now I want to take this q to the top. So now I am going to have 4q q to the power of 1 over 2. Now what's happening? I'm taking this to the top. When you move a variable from the bottom to the top, the exponent changes the sign. There is a 1 here, but we never write it. So this will be times, and then this q, when you take it to the top, is going to be a minus. Someone will ask, why are we multiplying? The inverse of, I don't know if it's the inverse of multiplication is division. I always say division and multiplication, they work hand in hand. And then addition and subtraction, they work hand in hand. That's why when you take a number from the left to the right, you minus it or you add it. So now here, when you take a number from the bottom to the top, you multiply it. Those are the rules. So it means that now I am going to have f of q is going to be equals to 4. And then now we need to multiply q to the power of 1 over 2 times q to the power of -1. When we multiply these two, we add their powers. So
Yes.
this will be q to the power of, let me write it here.
Up.
So this will be 4, then q to the power of half
Plus
minus 1.
1.
Yes, plus minus 1. So can you please help me there with a calculator?
Ma'am, isn't it minus 1 over 2?
Minus 1 over 2.
Paul, can we say minus 0.5?
Yes, you can. Again, it depends on your options on your multiple choice. It doesn't really matter. If your options are decimals, you can use decimals. If they are fractions, you can use fractions. It doesn't really matter. So now my function is fine. It's a function that looks like k x to the power of n. You see, it looks like that. You can only differentiate if you have a power. It must look like that. Now we can differentiate. When we differentiate f prime q is equals to, we say it's 4. Then we multiply. You take this. It's negative 1 over 2. This negative 1 over 2. And then it's q. And then after that, we're going to say negative 1 over 2 minus 1. We are doing the same thing over and over again. Then minus 1. And then now we answer. This will be, what is 4 times half? Negative half, it's negative. Half of 4 is 2. And then this is q to the power of, is it negative 3 over 2?
Negative 2 over 3. Negative.
2 over 3.
Negative 3 over
Tansi.
2.
Negative 3 over 2.
Negative 3 over 2. Because 1 plus half is 1.5. So this will be negative 2, then q, then negative 3 over 2. Every time, so in this example, I was addressing the roots, square root or a cube root. Every time you have this, you need to change it to this so that you can differentiate. You cannot differentiate if you have a square root or a cube root of or any other root, because this is what we call the power root. You must have the power because we need to minus. Let's do it again if you didn't get it. We're going to do number D so that it makes sense. So please
Ma'am, is this
go
one
back to the
finished?
recording. Sorry? Yes, I'm done.
Sorry,
I
ma'am.
can, if you want to make it positive, you
So
can
this
take
now,
it down.
you're
This will
done.
be,
You're not gonna times 1 over negative 1 over 2 times 4.
why? I already said 4 times negative 1 over 2.
Um,
It gives me a negative 2.
I'm not sure if maybe it's my network or
For what is 4 times negative half? Please do it for me with the calculator.
It's
Do it with
negative
the
2.
calculator.
Negative 2.
Negative 2.
Negative 2.
oh, okay. I'm sorry, ma'am. Maybe it's my network. Oh, yes,
Yeah.
yes. Now I can see it's my network. I'm left.
Oh, okay. Oh, I thought you
Because of the
said it's your
network. I'm sorry.
mates. Oh, the network. Oh, sorry. So this one, we can make it positive. again, just like we did here. You can say -2, and then you say you take this whole q to the bottom. So it's going to be a positive.
It's
Or I can say 1
-2,
over,
and
sorry.
said I'm sorry because it was my network. That was the
No,
problem.
no, yeah,
I was
no,
left
I got
behind
it.
because of network.
Yes. No, yes, I understand. No,
Yes, but now I can see that you're
okay. All right. So you can take it further and say this is q to the power of positive. You make this positive now. Again, it's going to depend on the multiple choice that you have on your assignment. If the question ends here, then you know you already have. If you have to simplify further, you can do it and simplify further. That's how we do it. But the rules are you must always leave your exponent as a positive. Those are the rules every time you differentiate. So let's do number D so that we see if we can, if we didn't get it. So now what am I doing at number D? I am combining all the functions. So I have 10, I have 5x, I have 1 over x to the power of 2. I'm combining the functions so that if you didn't get it, you can get it now. Now let's do it again. We're going to say, so this will be, I said, you cannot differentiate if you have something like this. Please change it first before we start differentiating. So I'm going to change that because I need powers. This is a power rule. So this will be f of x is equals to 10 plus 5x. The only person that I'm going to change now before I start is this fraction, 1 over. I don't want 1 overs. So I am going to change this one. It's going to be x to the power of -2. Because the rules are when you take a number from the bottom to the top, the exponent changes the sign. I'm going to write it here again. The rule says that if I have x, if I have 1 over x to the power of n, I must first write it as x to the power of -n. This is one of the rules of powers. This is the exponential rule, actually. It's a law. 1 over x to the power of n, you change it to be x to the power of -n. And then vice versa. If you have x to the power of n, -n, you change it to be 1 over x to the power of positive n. This too. Now let's start. Now because we have powers and the bases, now we can start differentiating. Please mute your mic. So I am going to have here, now I'm going to differentiate. I'm going to do it 1 by 1. So this is the derivative or differentiation of 10. This is with respect to x. Plus, I'm differentiating. Then d, there's nothing that I'm doing different. I'm doing it 1 by 1. It's either I have to write it this way or I can just differentiate. Let's differentiate. Let me not do this because it's going to be too long. I'll do it when we move down there. Let's differentiate. The derivative of a constant is a 0. I'm going to change this one. So this is a prime. So this is f prime x. This one, it's 0. A derivative of a number is 0. Plus, plus. Plus, plus. We said this is going to be 5. And then x. Oh, sorry, 5, then times. Sorry. There's a 1 here, ne? There's always a 1 here, by the way. There's always a 1 here. All right? So this is going to be times. Times. Sorry. So this is going to be times. This one. There's always a 1. If there's no power, there's a 1. So this is times. I'm using the K rule, if you remember it. And this is plus. Why am I saying plus? This is x to the power of this 1 minus 1. I am differentiating this one. This is the same as that one of k, x to the power of n. When you differentiate, it's going to be k times n, then x to the power of n minus 1. That's what I'm doing here on this one with 5x. So it's 5 times 1, then x to the power of 1 minus 1. If I have what? 5x to the power of 1. If there's no power, you put 1 on that variable. And then now we move on. Now we move on to plus.
Hey, ma'am. Sorry to disturb you.
Yes, I'm listening.
Is it possible maybe for some, so that they understand, can you introduce maybe brackets to all terms that you are differentiating, so that it's going to be easy for them to understand that each term you've differentiated in this manner, and going forward, so it's going to be easy for them.
Okay, thank you very much. Yes, yeah, think that will make sense. Thank you very much. Okay, let me do it again. Thank you very much. Okay, think that will make sense. Yes. Okay. Okay, yeah. So this will be f prime x. So I'm going to start with this one. This will give me a 0. So I'm going to use brackets. So this is a 0. And then plus. And then now we are differentiating this one. So this will be 5. And then times this 1. And then we say x. And then to the power of 1 minus 1. 1 minus 1. Then I close the bracket. And then now I'm differentiating this x to the power of negative 2. So the x to the power of negative 2 is going to be, so this is plus plus. Yes, it's going to be negative 2. Yes. Negative 2. Negative 2. And then x. And then to the power of negative 2 minus 1. Negative 2 minus 1. And then close bracket. Now we can solve. 0, 0. I really have to write the 0, okay? And then plus.
Sorry, ma'am.
Yes.
So what happened to the 10? How is it 0?
The rule says that the derivative of a constant is 0.
Oh, okay. Yeah, I get
Yes,
it.
the derivative, yes, of a constant is 0.
Yeah, ish.
Okay. No, don't worry. It's fine. You get used to it, it's fine. Honestly, it's fine. Yes. Okay. And then, so what is 5 times 1 is 5, eh? So this will be 5. And then x to the power of 1 minus 1, 0. All right. And then please, it's very important to write the 0 here. And then plus, what is the answer in negative? Why am I saying plus? Minus, this minus here. Let me write it in red. Minus, plus minus is minus. Minus, and then 2, then x. What is negative 2 minus 1? Negative 3.
It's negative 3.
Negative 3. So 0, 0, and then 5. What is x to the power of 0? Is 1.
1.
1. And then this is just a minus 2, then x to the power of negative 3. And then this is just the same as 5. And then negative 2, then we change this. This will be 1 over a positive, x to the power of positive 3. I'm just going to write it like this because the rules are you must leave the exponent. So someone might just write it like this, or you can write it as 5 minus, then you say 2 over x to the power of 3. No, I'm saying or.
Excuse me, ma'am.
Yes.
Ma'am, can you please go down a little bit? I just want to screenshot.
Wait until.
Yeah, ma'am. It's fine.
Okay.
Thank you, ma'am.
Thank you. The 1, it's 2 times 1, innit? That's why it's 2 over. It's 2 times 1. That's why I said or. You're not forced to write it this way. I said or, ne? 2 times 1 is 2. Now let's go to E. I'm going to do it again.
Can I ask a quick one before you go to E?
Yes.
There we have 1 over x
One,
squared.
one, that's
If
okay.
maybe we're having 3 over x to the power 2, is it possible that
Just as long as you
like
guys are
were
not
you
breaking
going to say
anything there.
3x to the power minus 2?
You are saying if you have what?
If maybe we're having 3 over x to the power 2, then when we change it, were we going to say 3x to the power minus 2?
Yes. Because when you move a number this to the top, it becomes a negative. That's why you see here, no? You can see here. Yes. All right. Let's move on to E. E, we have this. I'm going to do it again. I said you cannot differentiate if you don't have a power. In this case, we don't have a power. We even have a fraction that looks like this. So what we're going to do is we're going to solve this first. So every time you have a fraction like this, one number at the bottom and two numbers at the top. In maths, this is the same as f of x is equals to okay, let me write it like this. You must solve this first. So this is going to be equals to 5x. Then you give it this x at the bottom. And then plus, plus. Then you say 2, then over, then you give it x also. This x belongs to all of them. The denominator belongs to each and every number at the top. And then this will be, when you divide, this is going to be x cancels x, so we're going to have 5. And then this will be plus 2 over x. X divided by x is 1. A number divided by itself is 1. And I said to you, you cannot differentiate if you don't have a power. This x is at the bottom. I don't want it here, so I'm going to change. So therefore, I'm going to have my function is going to be 5 plus the 2. Then I'm going to take this x to the top. So I am going to have x to the power of negative 1. I said there's always a 1 here. If there's no 1, please put it for yourself. And then now we can differentiate because we have a power. Now let's differentiate. I'm going to remind you again. The rule says that if you have x to the power of n, when you differentiate, it's going to be n, then x to the power of n minus 1. If you have k being a constant, x to the power of n is going to be k times this whole thing again. N x to the power of n minus 1. Let's do it again. We have a k. And then if I have k, when I differentiate, my answer is 0. K being a number. Let's do it again. The derivative, f prime, this comma is a prime, x is equals to. The derivative of this is a 0. Derivative of a constant is 0. Then plus, you don't even need to write this. No, you should write the 0, sorry. Plus, this will be k, 2. And then times, what is my n in this case? It's negative 1 times negative 1. Oh, someone said I must use brackets. Okay, use brackets again. Negative 1 x to the power of negative 1 minus 1. You minus the 1. Negative 1 minus 1. Then this is 0 plus negative 2. Then x to the power of, I don't like writing this. Okay, x to the power of negative 2. Then this will be 0 falls off. Then I have a negative 2. X to the power of negative 2. And then I said I don't want the exponent as a negative, so I can write it as negative 2. Then 1 over x to the power of positive 2. Don't even have to. You can just write it as negative 2 over x to the power of positive. You can write it this way. It's up to you. So this will be positive 2. Or you can write it as negative 2 over x to the power of 2 because negative 2 times 1 is negative 2. That's how we do it. You must always have a power. That's why we call it a power rule. I am going to keep on reminding you about the rules as we move on. Again, let's move on. You have a fraction. I'm doing it for the last time now.
Sorry, ma'am.
Yes.
Can you please go up?
Mm-hmm.
On that stage of you said first it's 5x divided by x plus 2 over x. And
You
then on your
distribute
next,
the x.
sorry.
Yes. Continue.
Then on your next step, what happened to that x? Yes.
It got cancelled. This one, these two,
Yes.
they cancel each other. I get it. This
And
is
then we are
divide
left with x.
5 with 5. X.
With 5, sorry.
Yes, yes.
Okay, so the other x under
I
2,
took
we
it to
can't
the top.
cancel because it has a 1 on it.
Yes. We can't
Okay.
cancel because there's nothing to cancel it with. You can only
With.
cancel. Yes.
Okay, thank you very much.
My pleasure. If there was an X on top, we were going to cancel it with that X.
Okay.
Yes. All right. Now let's move on to I'm doing this one for the last time now. They're too mean. I was not aware that I'm doing too mean. They're too much. All right. I'm doing it for the last time now. Yes. Can I do it again so that you get it? Your question will be answered here. Can I do it here
Yes,
again?
please do it
Yeah,
again.
I'm going
Yes,
to
yes,
answer.
yes.
Yes, I'm going to answer your question. Again, you cannot differentiate if you don't have an exponent. And I don't want to have something like this. I'm avoiding this because I'm on the power rule. So I'm going to change this. So I'm going to divide. Oh, sorry. So this q belongs to these two. Everyone must get the q. So this is q to the power of 2 over this q. And then plus plus. If this was a minus, it's going to be minus. It's a plus plus. Q, Q. Then again, give this Q the Q. So now what's going to happen? Q squared, it means I have two Qs. Q squared is the same as having Q and another Q. So when you have two Qs and you divide it with the Q, the other one will cancel. You'll be left with one Q. Only Q. Q and Q. Let me write it here on the side. This one will cancel this one so that you understand where I got it. This one will cancel this one. I'm left with only Q. That's the Q that I wrote here.
Ma'am.
Fine. Let's move on. Yes.
Ma'am, can you go up? Yeah. So another way to do this one, since we are dealing with exponents here, it's also okay to say that q squared, since it's a fraction, it's in a fraction form. So it's gonna be q squared, meaning that q as a denominator, there's a 1 that's invisible there. So you can always say q to the exponent 2 minus 1.
Yes.
It's also fine
We
that way.
minus, it's also fine. It's exponential rules. It's also fine. Yes, thank you. It's also fine. And then q divided by q is 1. A number divided by itself is 1. 2 divided by 2 is 1. That's why I have a 1 there. A number divided by itself is 1. And then now I have a function. This is my function. F of q is equals to q plus 1. Now I can differentiate. When we differentiate, I said we need the powers. We have the power. So this will be, it's equals to, we start with this one. There's a 1 there. Like my lady said, there's a 1 here. So we're going to take that 1. Multiply. The rules, don't forget the rules. Ooh, sorry. Don't forget the rules. Do not forget the rules. The rules are, I'm going to write it here again. The rule, x to the power of n. When you differentiate, is n x to the power of n minus 1. Let's do it. There it is. It's 1. My n is 1. 1. And then q. And then 1 minus 1. 1 minus 1. Plus, plus. Plus. And then I said that the derivative of a constant is 0. Derivative of k is 0. Derivative of 2 is any number. So this will be 0. 0. Now we are going to have q, because 1 times q is q to the power of 0. 1 minus 1 is 0. And then now, what is q to the power of 0? Q to the power of 0 is 1. Any number to the power of 0 is 1. Any number to the power of 0 is 1. I'm going to write it here so that you get it. Any number to the power of 0 is 1. X to the power of 0 is 1. 2 to the power of 0 is 1. Any number to the power of 0 is 1. So q to the power of 0 will give me 1. That's it. 1 times q, it's 1. This is 1. Even if I wrote that 1 here, it's going to be 1 times 1. It's still 1. Nothing has changed. This is what we call the power rule. You need the power. Is it fine? That's the power rule. Please keep on repeating this every time so that you get it. And if there's anything you need to know, I'll keep on doing it. Those who did pure maths or maths, they're fine. But those who didn't do maths, please, I'll keep on writing the smaller details that you need to know when you are dealing with differentiation. All right.
Sorry,
Yes.
ma'am. Can you please, when we are done, save this in PDF and upload it on our additional resources?
Okay. All right. It's fine. I'll do that.
Thank you. Thank you.
All right. And then now let's move on to exponential and natural log. What? Why didn't I write this is number 2? Supposed to be rule number 2. Okay. All right. It's fine. You just correct it. So this is supposed to be rule number 2. Yes, it's 2. Wait, what's happening here? Okay, this is 3, I guess. Oh my word, please, you'll correct it. It's fine. So this is another rule. Exponential and natural logarithm. These are rules. Oh, sorry. Okay. So here we are saying that if you are given, if you are given a function, it's y is equals to. Please understand that f of x and y is the same thing. I'm going to write it here so that you remember. Y is the same as f of x. Please ignore the left side of these functions. Whether I say y, whether I say f, same difference, same thing. If you are given this function, y is equals to e to the power of x. Every time when you have something like this, when you differentiate it, the derivative of this will always be the same. It's not going to change. The derivative of e to the power of x will always be e to the, only e, please, only e. Every time you see something like this, just know that it doesn't change. It stays the same. It stays the same. And then the derivative now, when you're e, the power has a number next to it. A is a number, it's a constant. A is your constant. So when you have a constant next to this power, when you differentiate, your answer is going to be, you take that number, you put it here, and then you just say e to the power of ax. A being a number, any number. Again, you'll see it when I do an example. The second one, this was the first one. This is for exponential and logarithm functions. The second one is when your function is, please mute your mic.
Hello?
When your function, please mute your mic. When
Hello?
your function, please mute your mic.
Hello, ma'am.
Yes, I'm still teaching. I'm not done.
I have a screen.
Sorry? Hello? Okay. All right. I'll answer your question when I start doing examples. I think it will make sense. Another one is if your function is y is equals to ln. So this one we call it ln. In ln, this is ln. Ln x. When you differentiate anything that has ln and then the bracket there is going to be 1 over x. So if this was my ln was ln, maybe let's say x plus 1. When I differentiate, my answer was going to be 1 over x plus 1. Whatever is inside the bracket, that's how it is with exponential and log. It's going to make sense when I do the example, and I'm going to keep on doing it again. So I have what we call the chain rule. We did the exponential, sorry, we did the power rule. Now we're doing the chain. With the chain rule, you need this exponential and natural. When we're going to be deriving, we're going to include these two. So these are the functions, this function and that function. Every time you see the ln, when you differentiate, it's going to be that. Every time you see e, it doesn't change. But if the power of your e or the exponent there has a number, that number must come here when you differentiate. Again, you'll see it when I do the example. The chain rule says that the derivative of a composite function. So when you talk about the composite function, it's a function that has more than one function. It has two functions. It is formed by combining two functions together. It will make sense when I do it. So the chain rule says that the derivative of a composite function is the derivative of the outer function. Then you multiply the outer function by the derivative of the inner function. Again, it's going to make sense when I do it. So your function can either be given with y is equals to, or your function can be given as f of x. It doesn't really matter. Let's see how we do it when I do an example. It will make sense with the example. Please just bear with me. So, all right. So the question says, differentiate each of the following functions. I'm going to do it and do it so that it makes sense. I'm going to incorporate the ln and the exponential function. Step number 1. We need to know the outer and the inner. Please mute your mic.
Sorry, excuse me. Can you just up the page, please? Sorry, interrupt you.
Oh,
teacher.
okay. All right.
Okay, thank you so much.
Okay. Oh, sorry. Oh, sorry.
No, it's okay.
Oh, you're done. Okay. All right. So step number 1, we need to know the inner and the outer so that we can follow the chain rule. So we are going to start. I'm going to let. You don't have to say let. So I'm just going to say let for now. When I'm giving a function like this, so I'm going to let. I'm going to start with my inner. So my inner in this case is going to be, I'm going to say let u. We always use u. I'm going to say let u be 2x plus 3 because here I have what we call a composite function. So this is a composite function. So I'm going to let u equals 2x plus 3. 2x plus 3. And then when I'm done now, I'm going to say now, if my u is 2x plus 3, then it means that this is going to change. Can I just use... all right, I want to use red, sorry. Just want to use red, just bear with me. So I'm going to say, let this be 2x plus 3. So if my u is 2x plus 3, it means that my function is going to change. It's going to be y is equals to u because I said 2x plus 3 must be u. So it means this will be u. Then to the power of 5. So it means that this function will be u to the power of 5. So here, this is what we call the inner function. And in this one is the outer. You don't have to write this. I'm just writing it for now so that it makes sense. So now I'm going to start differentiating. I'm going to start differentiating this y. So I'm going to start with this. So I'm going to differentiate first dy over dx du. I'm going to differentiate this. So this will be, when you differentiate this, remember I said this is going to be, you take the 5, you write it here. So this is 5, and then u, and then 5 minus 1. We did this, please. We did this. I did this with you. When we differentiate, this is going to be 5. You take this 5, you write it here, and then you say 5 minus 1. This one we did when we were doing the power rule. This one we did.
Yes, we did, ma'am.
We did this one. So this is 5, and then u to the power of 4, because 5 minus 1 is 4. This one we did. And then now I'm going to differentiate. I was differentiating the outer, and I'm going to differentiate the inner. This is the outer, this is the inner. Let me write it here. I was differentiating the outer. I said the left-hand side is not that important. I'm interested in you differentiating. So I'm going to differentiate the inner now, which is 2x plus 3. So this will be the derivative of u, because it's u, over the derivative, so the derivative of u with respect to x, because my variable is x. That's what it means. Derivative of u with respect to x. Let me use this. Again, we did this. We know how to differentiate. We said when you differentiate, you must have a power. We know how to differentiate this one. This is going to be 2x plus 3. Oh, sorry. What am I doing now? Du. So, okay, let me write it like this so that it makes sense. I'm just going to write it like this so that you can see it. So this is 2x. Now let's differentiate. I'm just rewriting the whole thing. Now let's differentiate. When we differentiate this one, there's a power here is 1. So this will be 2 times, someone said I must use brackets, so I'm going to use brackets. We are differentiating 2x plus 3. I'm starting with 2x. So this will be 2, then times. The power of x here is 1. I'm repeating the same thing. 1. X. And then it means it's going to be what? 1 minus 1. 1 minus 1. I'm differentiating 2x. And then plus. The derivative of 3 is 0. Thank you. 0. And then now let's continue. This is 0. Now we can solve. So our answer for this one is going to be 2 times 1 is 2. Then x to the power of 0. And then this is x, any number to the power of 0 is 1. So your answer is 2 for this one. The answer is 2 for this one. And then now, the chain rule, I'm going to write the rule. The rule says that the derivative, the rule, chain rule is here. The chain rule, I did it. The rule says that the derivative, okay, let me just write it here because I don't have. Derivative the rule says that the derivative of y with respect to x is equals to, this is the rule. the derivative of y with respect to u times the outer times the inner, or inner times outer. That's what it says here. It says that the derivative, it says here the derivative of a composite function. What is my composite function? Is this one. Is equals to the derivative of the outer is this one, multiplied by the derivative of the inner. What is the inner? Is this one. The derivative of the outer, we got 5 u to the power of 4. Inner, it's 2. Outer, inner. Very important. You must find the outer and the inner first. This is my outer. This is my inner. Those are the derivatives. So it means that now I'm just going to substitute, replace. The formula is this one. So I'm just going to say my answer is going to be the derivative of the outer. It's 5 u to the power of 4. And then times the derivative of the inner, it's 2. So my answer is going to be what? 5 times 2, it's 10. Then u to the power of 4. That's how we derive using the chain rule. Chain rule. And then remember we said that our u is 2x plus 3. So you must always change back the u. This will be 10. And then my u, we said it's 2x plus, so you must change it back. It's 2x plus 3. Change the u to be 2x plus 3 because we said that we're letting the u be 2x plus 3. Then this is to the power of 4. That's how we derive a composite function. It takes time. You need to be patient and practice. It takes time. So please practice with your activity and also practice with your examples. I'm going to do it again using the exponential function. This is an exponential function, is an e. Don't forget the rule. We said that the derivative of an exponential, the exponential function, it stays the same. It doesn't change. But this is a chain rule. We must first find the outer and the inner. Someone will ask, how will I find the outer and the inner? You'll see it here. 2x plus something to the power of 5. You see it here, 5x plus 7. E to the power of 5x plus 7. This is where you can use the chain rule. We can't use that other one. So now let's do it again. I'm going to do it again. You let. You don't have to write let. I'm just going to say let. Let u. I'm going to do it again. Let u. My u in this case is going to be what? 5x plus 7. I'm letting my u be 5x plus 7. And then after this now, if my u is 5x plus 7, it means that my function is going to be y is equals to e to the power of u. If I'm saying my u is 5x plus, so it means that my function is going to be this. So now what happens? This is my inner and this is my outer. Now I must derive my inner and my outer. Now we are going to derive. Using what? The power rule. So we're going to derive. You must get used to deriving. This is the derivative. So this will be a dy. Honestly, it doesn't really matter what you write this side, but please derive over du. I'm deriving with respect to u. So remember we said that this means that, let me just write it like this. Oh, but yeah, let me just do this, sorry. So this is the derivative of e. Remember we said that. The derivative of exponential function is still stays the same. Here it is. We said that if you are deriving this, it's not going to change. It's still going to be e to the power of x. Same thing happens. It means that if I'm deriving e to the power of u, it stays the same. It's still going to be e to the power of u. And then now let's derive the inner. Inner, it's this one. So the derivative of the inner, I'm doing the same thing that I was doing. The derivative of the inner with respect to x is going to be, just do it this way. Honestly, it doesn't matter. I just want my answers. So this will be 5x plus 7. U is 5. This is 5x plus 7. I'm going to do it. So this will be the derivative of 5x. There's a 1 here. I repeat, there's always a 1 if there's no 1 on your x. By now, you must know that the derivative of x is 0. Is 1. Sorry, I can't keep on writing this. Let me write it here. The derivative of x is 0, is 1. Oh, but let me just do it. Okay. So this will be, you take the 5, then times. Then this 1 is here. 1. 1 is represented by n. This is 1. And then x. This is x to the power of 1 minus 1. I'm doing what I've been doing all along. 1 minus 1. I'm deriving 5x. I'm using the longest way. You don't have to. This is plus. The derivative of 7 is 0. It's not going to change. It's 0. So it means that my answer is going to be 5x to the power of 0, which is 5. If you can check, I'm doing the same thing that I've been doing. This is 5. What I did on my left side, it's 5. This is what the derivative of my outer. This is the derivative of my inner. And then the chain rule says that the derivative of a composite function is equals to the derivative of your outer times your inner. Then we do that. Therefore, I'm doing that again. I'm going to write it again here. The derivative of my composite function with respect to x is equals to the derivative of my outer times the derivative of my inner. Whether you say inner times outer, outer times inner, it doesn't matter. Your outer, you got e to the power of u times your inner, you got 5. What does it mean? I am going to have 5 e to the power of u. What is my u? 5x plus 7. This is 5 e to the power of 5x plus 7. This is how it's done. 5x plus 7. This is how we differentiate using the chain rule. Questions?
Yo.
So do we always have to start with the outer every time, or we can
No,
either
you don't have
and
to. You start with either inner or outer.
okay.
It takes
Thank
time, yes. So it takes time. I understand that you're not familiar with differentiation, but please, you have to practice. Do it step by step. It will make sense. Take your assignment and do it, or do the activities first. It takes time, but you do it step by step. You'll be fine.
Sorry, ma'am.
There's no running away. Yes?
Sorry, I was a bit late, but I see in your A,
Yo.
here in your A, when you make that U, that's outer when you say y is equal to u to the exponent 5, right?
Mm-hmm.
And then on your B,
Here's
that's u.
here's my function. Yeah.
Yes, your outer u becoming the exponent. I know I'm late, but can you
It's
give me
here.
a clue how?
Check the function. My question is y is equals to e to the power of 5x plus 7. And then I let my u be what? 5x plus 7. So if my u is 5x plus 7, it means that this will be what? Y is equals to e to the power of u. Yes.
Oh, okay.
You
Thank
see it
you.
now?
Yes. Thank you.
Yes. So don't worry. If you miss the other ones, you'll just watch the video again. Eh?
No, all right, ma'am. And
Yes.
practice a lot because this is a lot of work.
Yes, I know it is a lot, but you need, yeah, you just need to practice. You'll be fine.
Okay, miss, thank you.
All right, let's go to C. I'm
Sorry,
going to do it
before you move.
again. Yes.
Sorry, ma'am, before you move.
Yes, yes,
Can you go up a bit? I
yes.
just wanted to ask that you should be always should be always equal to the function or to the equation, like 2x plus 3, or
Yes,
okay,
always
yeah.
a binomial, yes. The one with two terms, yes. Let's do C again. It's gonna make sense. Let's do C again. So when you look at C, what's gonna be your U? Let me ask you a question. What's going to be your U?
6x minus 4.
Exactly. Exactly. 6x minus 4. That's my U. So we're going to do it again. I'm going to say let. If you didn't get it the first time, you must get it now. Let's try. And remember, this is the log function. The log function said that if I'm given ln x, when I differentiate, I'm going to change. It's going to be 1 over x. Don't forget that. I'm just reminding you this one. You'll see. If you didn't get it, it will make sense when I do it. I'm just going to take it. Let's start with the let u before we differentiate, because it's a differentiation. Let u. So our u is going to be 6x minus 4. So u is going to be 6x minus 4. So my u is 6x minus 4. And then now if my u is 6x minus 4, it means that this is going to change. It's going to be y is equals to. This function is going to change. It's going to be y is equals to ln, and then this is u. It's going to change. Then this will be my u, because we said u is 6 minus 4. After we do this, now we differentiate. This is my outer, this is my inner. Let me just write it. Outer. It's not really important to write this. This is my inner, ne? Sorry, this is the one that is inside. This is inner. It's not important, by the way. I'm just doing this. This is outer. Now I differentiate. Now we
Ma'am, it
differentiate.
is actually important. You see what you're doing there is very
Okay.
important, ma'am. Very important.
Okay. So this is inner. This one is outer. Okay. I'll keep writing it. Thank you. So it's going to be a dy. Now we are differentiating the outer with respect to u. So this will be the differentiation of ln. I said the differentiation of ln, it becomes 1 over. Here it is. So this will be 1 over u. That's the differentiation of a ln. 1 over u. Now we're doing the differentiation of the inner. This was just for the outer. Then now I'm doing this one of u. Now I'm going to say the derivative or differentiation of du with respect to x, because my variable at u is x, this one. So I'm going to differentiate. So this is derivative of 6x. Okay, let me use my red. 6x minus 4. Now we differentiate. We've been doing this. We're doing it again. This is going to, I'm going to start with 6x. It's going to be 6 times. I said there's always a 1 here. If there's no number, there's a 1. It's 1. So it's going to be 1. And then x to the power of 1 minus 1. 1 minus 1. If you missed it before, you'll get it. If you didn't, if you're not sure when you started, you can watch the video, but yes, just move with us, you'll be fine. And then now this is minus. The derivative of 4 is 0. And then this will be equals to 6, then x to the power of 0. I am doing the same thing that I've been doing. I did it. It's here. Again, it's here. I've been doing the same thing. It's the same. Nothing has changed. We're doing the same thing over and over again. So this will be to the power of 0, then minus 0. I don't need to write the minus 0. So this is 6. Now I have my derivative. So I'm just going to say, therefore, the derivative of the composite function is equals to the derivative of my outer times the derivative of my inner. So this will be derivative of my outer, because this is inner. Derivative of outer, 1 over u times 6. There's no order here. So this will be 6. And then 1 over your u is 6x minus 4. 6x minus 4. Or your answer can be written the 6 times 1, it's 6. So it's 6 over 6x minus 4. Please, you cannot cancel 6 and 6. Please, this is your final answer. You cannot cancel the 6 and the 6. This is your final answer. When you are writing your assessment, you know that when you are here, it's either the answer is this one or that one. 6 times 1 is 6. That's why we wrote the 6 there.
Ma'am,
Yes.
can I please ask something here? I'm lost. So why do we have there by the outside? You see, derivative of y over derivative of u is equal to d over derivative of u. Why do you have lapana u1 over u, whereas u oguma bracket there's no -1 inside there.
This one is 1 over u because it's the outer. Outer times inner. Your outer, your answer was 1 over 2, 1 over u. That's what I did here. This, the answer is this one. This one, the answer is 6. So when I replace my u, we said u is 6x minus 4. I replaced the u with 6x minus 4.
Or maybe you can explain it in the sense of saying that the differentiation of the ln is always 1 over u. Maybe that's the
Yes.
confusion.
I wrote it here. It's here.
I also think that's the confusion because I also made the same mistake when I was doing it by myself.
Oh. Okay, so is it fine now? The differentiation of a ln is 1 over x. That's why I wrote it before I started teaching. So differentiation of ln u is 1 over u. And then the rule says that the differentiation of a composite function is equals to the derivative of inner, outer times inner. My outer, the answer is 1 over u. My inner is 6. This is times. I just simply replaced my u with 6x minus 4 because the derivative of my outer is 1 over u. I took it from here. That's why it's important to do these two first before you multiply. Others, they can do it without doing the other steps, but it's important.
Well, ma'am, I was about to ask, like, how do you do it that way? Because this one seems long.
Which one seems wrong now?
Seems long. Like it's long steps. You
It's
know, if
always
the
long. Yes, it's not gonna be short, it's long.
but you said others do it without having to go through all these steps. So I was just
Yes, others, they jump this. They're not gonna do, they derive straight from here. They just derive and write the answer. So I have to teach it this way so that you understand. For people who didn't do pure maths, I have to do it this way, the longest way. Others, they just derive this and they just substitute here. And they derive that and substitute. They know that they already know that the derivative of 6x is 6. They know that the derivative of ln u is 1 over u. So they jump these 2 steps. So when I teach, I cannot jump the 2 steps. So when you, with practice, when you do it, you can jump. If you are used to it now, with practice, you'll be able to do it. You can jump. Because remember, your assessment is a multiple choice. The most important thing for me is the final answer. Can you get to the final answer? So I have to show you how to get to the final answer. You understand?
No, I understand, ma'am. I just wish that maybe if we can do one, the shortest way, maybe
Yes,
just to show us,
yes,
like.
yes,
I
please.
can't. You want me to do it the shortest way? I can't. So how are you gonna understand if I do it the shortest way?
Now we
Okay.
already see the longest way,
Oh,
right?
okay. Yeah, let me do it the shortest way. So please, you asked for it. I'm going to do it. So don't complain. Okay, let me do it the shortest way. All right.
Yes, please.
So I'm going to start by letting I let u. I'm gonna let u equals to what's gonna be my u in this case?
X plus
X
2.
plus 2.
X plus 2. So this will be x plus 2. So if my u is x plus 2, it means that I'm going to have y is equals to 2 over u. And remember, I said that you cannot differentiate if you don't have a power. So this one is, I need to change it back. I need to take the u to the top. So this will be 2, and then u to the power of -1. Remember, when you take it to the top, it changes the sign. So this will be u to the power of -1. Now I can differentiate. So I'm going to differentiate. You said I must do it the shortest way. So I'm going to say, therefore, it means that my dy over dx is going to be the derivative of 2 to the power of negative is going to be bracket 2 times -1. I'm doing it the shortest way, -1. And then it's going to be u, sorry, to the power of 1 minus -1. So it's going to be to the power of -1 minus 1. Sorry, to the power of -1 minus 1. And then we said it's going to be times, so it's times. And then the derivative of x plus 2 is going to be, there's a 1 here, remember? So this will be 1, and then x to the power of 1 minus 1. So it's going to be 1, and then x to the power of 1 minus 1. I'm deriving this one. 1 minus 1. Then I'm done. Then I just solve. So this is -2. Then u to the power of -2, because -1 minus 1 is -2. And then times x to the power of 0, we said is 1. Eh? So this is just 1. And then I said that I don't want my exponent to be negative. So this will be, okay, this times this, it's -2, u to the power of -2, so that don't ask how I got it. So I'm just doing it. And then now this will be -2. And then times, let me just put times, then it's 1 over. We said we want this to be positive. So it's 1 over u to the power of +2. So, not or, sorry. Yeah, so this is just, it's up to you. -2 over u to the power of 2. Is it fine? This is the shortest way.
Are we
Yeah,
not
no, it's cool.
substituting u in this case?
Sorry?
No, it's not fine.
Are we not
Exactly
Not
my
substituting?
point.
fine. The longest step
Exactly my point.
is the right one.
Exactly my point.
This one is wrong.
It's very
Thank you.
confusing. Oh,
Exactly my point. You
It's
asked
very
for it.
confusing, ma'am.
I gave it,
No,
you asked for it.
we are against
It's
this
even
method.
confusing. Yeah.
But guys, we
no,
just
it's not.
wanted to see it. That's all. We
But
just wanted to
guys,
see.
guys,
Okay,
that other
let's,
guy just
I have
wanted
to
to
move.
see. It's not
Yes, he
that
wanted to
he
see.
just
So now you
wanted to
see it.
see.
And
And
I
our
hope he
He
got
sees
it.
teachers
the
just
reality
showed
of this
us.
thing. It's not easy,
See.
ma'am.
So I hope he got it. Ne?
Olane, I'm going
I
to
hope he
suggest
got
that
it.
moving forward, allow others to understand the fundamentals,
Yes.
especially those that haven't done maths. A few of us
Exactly.
understands how you quickly got to it, but allow those without fundamentals to get it.
To get it. Exactly my point. So that's the whole, that's why I wanted to do it the longest way, because the shortest way, if you did maths, that's how you're gonna get it. But if you didn't do maths, you still want to see the steps being repeated. Because you'll be writing your exams and then it's a multiple choice, then you still have to solve. But I hope the guy who asked for it, then he's fine.
No, I'm fine, ma'am. Thank you so much. I just
You
wanted
get
to
it,
see
ne?
how it's done. Yes.
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 So
Thank
that's
So,
you.
ma'am, is that the final answer? Wait,
that's the
before we
final.
move
Oh
on.
no, it's not the final
It's
answer. We
not the
have to
final
change to
answer, yeah.
you. Yes,
Yeah.
we have to change to you.
Yeah.
Yeah. Okay. Let me just do this because time is not on our side. So yeah. So you change it to you. So this is just gonna be -2. I don't have a space here. So this will be -2 over. Then it's this x plus 2 is. So I think, yeah, so this is going to be x plus 2. That's how it's done. Okay, or squared. Sorry, squared, yes. So I have to do the product rule because I can't go to that. Let me see. Yeah. So product rule, so it's the same, we're doing the same thing again, ne? The only difference here is that there's a rule for product rule, you plus, for quotient you minus. But let me do only the product rule because it's too long. I will continue with the quotient rule when we meet because I feel like this is, yeah, it's too long. Ne? So I'm just gonna do the product rule. I'm going to do what I've been doing. The most important thing is you have to know the power rule. Power rule is your basic. You have to know how to differentiate. And then the chain rule, you have to know the chain rule. The chain rule is when you have a fraction and then the bottom number, when you have a composite function actually, where you have like two terms, like 6x minus 4, x plus 2, and then you have like to the power of two numbers again, two terms also with an exponent. That's how when you use the chain rule. And then now we have the product rule. The product rule is when you have two terms, two terms being multiplied together. There's no plus in between. So this is not x squared plus. So that's when you know you're going to use the product rule. This is not x plus 4 and then plus ln. There's no plus ln. It's just times ln. There's a multiplication between x plus 4 and ln. There's a multiplication between x squared times, there's a times here. If there's no sign, it's a multiplication. That's when you know that you're going to be using the product rule. Again, remember your assessment is open book. That's number one. And
Sorry, ma'am.
also the answers is the final answer. You have to choose it's a multiple choice. So
Sorry.
open book, multiple choice. Yes.
Oh, I'm so sorry to disturb you, ma'am.
Okay, it's fine.
Yeah. So, like, going back to the question, the question that we were doing, yeah, accessible, ma'am. So, Ulin is same as question. Okay, I'm sorry for those who didn't do in maths, but I just want to make sure because I'm confused, like, I don't want to lie. So, the accessible, ma'am, is it the same as the first principle? The one with lean?
The lean.
Yes, the one
No,
with lean.
you
Can I?
didn't do lean in maths. You only did first principle is differentiation.
Yes,
Lean is not, it's not lim. There's a difference between lim and lean. This is in your calculator if you can check. It's lean. This is lim. Limit. We're not doing the same thing. Ne?
So
It's
if like,
yes.
so if I try to like solve the same like question using the first principle method, it won't give me the correct answer.
The first principle.
Yes, using the first
No,
principle method.
no. No, you can't use the first principle. You use the first principle on the first one, the power rule. This one. This one, the power rule. This one. What you've been doing. You can use first principle here, but first principle is the longest way. You can't. Please don't use first principle. It's too long.
All right, ma'am. Thank you.
Differentiate, yes. So these are what we call exponential and natural logarithm functions. So we are saying that if we have to differentiate exponential, this one, the function, this is what happens. If we have to differentiate this logarithm, this ln, this is for how you get the answer. That's it. Don't use first principle. First principle is too long for differentiating.
Okay, thanks, ma'am.
Okay. All right. So now let's see the product rule. The product rule says that if you are given f of x or y is equals to, I said or so that you can see. You are going to say the derivative of this times this plus the this times the derivative. So it means you need to find the derivative of ux and then multiply it with this function, and then take the function of ux and multiply with the derivative of the other. Let's see, what do I mean? So this is just straightforward. When you are differentiating, you can write everything is fine, it's exponents, and there's no need for, yes, this is fine. So it means that I must have ux and vx. So I'm just gonna say u. My u is ux is, let me use a color. So my ux in this case is going to be x squared. Ne? So ux is x squared. My ux is x squared. And then my vx, we're just using the rule. And vx, my vx is e to the power of x. So when I differentiate, okay, then the derivative of ux, this will be u prime x. This is the derivative of ux. Is going to be what? 2x to the power of 1. Can someone tell me, do you know how I got the 2x to the power of 1? I'm differentiating.
Yes.
It's
Yes.
2.
It was
Yes,
2
it's 2.
times
Yes.
2 times x
And then 2
times
minus 1.
1.
2 minus 1.
Thank you. Yes. You see, when you practice, it's gonna make sense. And then, mute your mic. Banyana, mute your mic. And then we said that the derivative of an exponent e to the power of x, it doesn't change, it stays the same. If you remember.
Yes.
So now we are done. So therefore, the rule says that the f prime x is going to be equals to u prime x and then times vx and then plus ux times v prime x. Now let's just replace. We're replacing u prime x, it's this one. It's 2x. 2x. This is 2x. Let me just write to the power of 1. And then vx, it's just, where is it? Vx, not v to the, not prime, it's just e to the power of x. Plus ux is this one. X squared. Ux is x squared. V prime x is just e to the power of, it didn't change. E to the power of x. And then we're done. Then this times this is just 2x. Does it stay the same? Do you simplify? Okay. E to the power of x, then plus, which one comes out? Okay, let me just write x squared, then e to the power of x. And that's it.
Ma'am,
That's it. Yes.
why is there an addition? Like, why are we supposed to add? Like the addition
It's
sign,
the
where
rule.
does it come from?
It's the formula. It's here. It's the rule. Formula, rule.
Why
Rule.
did they introduce the positive sign, like the addition
It's a
sign?
product.
Why?
It's product rule.
Product rule.
Product rule, we plus. Quotient, we are going to see we minus.
Oh, okay. Oh.
Yes, it's the rule. It's like that. It's just the rule. It's a rule.
Miss Masejo, before you
Yes.
move further, you remember when we were doing the chain rule, you said that u is the one that has 2 terms. In this case, you chose u as x to the power 2. Is it because x to the power 2 is the same as x to the power 2 plus 0, 0 as the constant?
No, I just
Then
gave
why?
it. You give it. It doesn't have to. It's not fixed. Remember here, I said let. Let, it means that you are letting it. It's not always like that. If you choose to use another let, here, you're talking about this, ne? Here. Are you talking about this?
No, I'm talking about the product rule, but then I'm referring to the chain rule.
Product rule and chain rule are two different things.
Yes, they are. But so okay, the definition of U in the product rule, is it the same as the definition of U in the chain rule?
No.
Okay, maybe that's why then.
Yes, in the product rule, U is a function. It's U, yes, U, X, V, X. Here it's a function. It's just acting as a function. Here I was just letting it to take this function as 6x minus 4. I guess they're both functions. Yeah. I guess they're both functions, yes. But we can't have, it's the same. Let me just say it's the same. But this is a product rule. This one is the chain rule. It's the same. I think you have a point. It is the same. Because if I was to write this, I was going to say du over dx. Can you see here?
Yes, ma'am.
Yeah, you're right. It's the same. It's a function. Du over dx. I'm deriving u with respect to x. I'm deriving v with respect to x. Yes. Yes, it's the same. Sorry. It's the same. I guess it's the same.
So ma'am, basically that U there on the product rule, that can still be A, right? Like it can still be A or B or whatsoever.
Yeah. A of x, v of x.
I think
It's a
that's what
function
they
though.
were.
It's not a letter. It's
Yeah.
a function. Yes.
Yes, it's not a
Yes.
letter, it's a function.
It's a function. Thank you.
All right, thank you.
All right.
Ma'am,
It can be any letter. Yes.
ma'am, can you please just explain how you got to x? Because I didn't hear when they were explaining.
I derived the derivative of x squared. I used the, I'm going to write it again. Power rule. Power rule says that if I have x to the power of n, when I derive it, it's going to be n, then x to the power of n minus 1. What is my n here? My n is 2. 2. Then what is 2 minus 1? 2 minus 1? It's 1. There it is. Yeah, you have it. There it is. Can you see?
Yes, ma'am. Okay, thank you, ma'am.
All right.
Thank you so much, ma'am.
Pleasure. Okay, let's do the last one because I can't do the quotient rule. Actually, I can, but it's going to be too long. Okay, so let's do the product rule. I'll do the quotient when I start teaching the other part. So the other example, I'm going to do it again. So if it's a y, you can write it as dx over dy. Like it's the same thing. Nothing is changed. Whether it's y, whether it's x, we're doing the same thing. So we're going to say our ux. We do the ux. Ux, I'm going to say it's x plus 4. When I derive this x plus 4, the derivative, it's going to be, okay, should I do it the longest way? X, then 1 minus 1, then plus 0. Yes. So this will be x to the power of 0, and then plus 0, and then this will just be 1 because x to the power of 0 is 1. Remember, it's n x to the power of n minus 1. So there's a 1 here. So it's 1, then 1 minus 1. That's for ux, that's the derivative. So it means that the derivative of ux is 1. And then now we do the v. So I'm just going to say and, I'm going to use a black. So d, I'm going to say my vx, we do v, ne? Yeah, vx is ln x. And then if I derive the ln x, we said that from the rules, the derivative of ln x is 1 over x.
X.
Yes, now we can start. So therefore, a dy over dx is going to, please, these two things are the same. There's no difference, actually. There's no difference. My u prime x is 1. U prime x is 1. Sorry, this one is this. I'm doing the same thing. It's 1. And then use brackets and then Vx. Vx is ln x plus plus. And then now we say ux. Our ux is x plus 4. Ux, it's x plus 4. And then bracket, our v prime x is 1 over x. And then this is equals to 1 times this, it's still ln x. And then this one is going to be plus x plus 4 over, it's a fraction, over x. I hope I did it correctly. And
That's
this is
correct, ma'am.
it's correct, ne? Yeah, this is ux, u prime x. This is vx, and then this is ux, and this is v prime x. It's still the same thing. Nothing has changed. That's how we do the chain product rule, sorry. So it takes time, please. It takes time, but please be patient. So I will continue with the quotient rule when we meet Monday. And then, yeah, because this is too long. I know it takes time, and please don't be afraid to ask questions. Our urgent academics are there to help if you need help. But please do practice. Before you ask questions, it's wise to go through your activity so that when you ask your urgent academics, you can ask them based on what you did so that you can correct yourself. All right. I'm going to stop the recording because it's too long, and then you can ask questions if you have questions. I'm going to stop the recording now. Yes, Babalwa.
How are you?